Continuing on in section 4.7 here, we're going to keep writing recursive formulas for the sequences and finding the 9th term of the sequence. So here, again, feel free to pause and give this a try if you'd like. Our recursive formula is a of 1 equals the amount of our first term, and a of n equals the amount of the term before plus our common difference. So here, to go, I start at 23, that's my first term. To go from 23 to 35, I add 12. Here again, I add 12. Here again, I add 12. So 12 is my common difference. That's what we add every time to the term before. So I take the term before, add 12 to get my value. Then I take the term before, add 12 to get my new value. And we're going to keep doing that until we get to the 9th term. So here I get 71, 83, 95, 107, 119, and that gives me my 9th term. So the amount of my 9th term, or the value of my 9th term, a of 9, is going to be 119. See here, feel free to pause and give it a try if you'd like. Again, my framework, the part we have every time, is a of 1, it's the value of our first term. And then a of n means the value of any term is the value of the term before it, a of n minus 1, plus our common difference. Here my first term is 7.3. My common difference, to go from 7.3 to 7.8, I add 0.5. Here again I add 0.5. Here again I add 0.5. So my common difference is a positive 0.5. This right here is everything I need for my recursive formula. I'm going to keep doing that now, keep adding the same common difference until I get to our 9th term. So my 9th term, a of 9, is going to be 11.3. And last one here, feel free again to pause and give it a try. Again, the value of my first term we need, and then the value of any term is going to be the value of the term before it plus our common difference. So here my first term is 97. My common difference here, each time it looks like I go down 9. I subtract 9. So my common difference is actually a negative 9. We wouldn't need both signs here. We could write this as a of n equals a of n minus 1 minus 9 if we wanted as well. Since we go down, our number gets smaller, it's negative. So there is our recursive formula. We need to find our 9th term, so I'm going to keep subtracting 9. Until I get to my 9th term. So the amount of my 9th term is going to be 25. Now adding our common difference every time worked fine when all we were finding was the 9th term, but if we wanted to find the 90th term, that gets pretty tiring pretty quickly. So we can find the value of any term of an arithmetic sequence using a recursive formula, but we can also write the sequence using an explicit formula, which is going to make it a whole lot faster and easier. So an explicit formula is a function rule that relates each term of a sequence to its term number, and they have this on page 276 in your book. It's a of n equals a of n equals a of 1 plus n minus 1 times d. Think about the sequence here, 1, 3, 5, 7, 9, 11. Let's say we wanted to know the 6th term. Here we know it's 11. If we were looking at this, to go from 1 to 3, we add 2. Then we add 2. Then we add 2. Then we add 2. Then we add 2. We can use the fact that every time we're adding the same number here to our advantage. We can write repeated addition as multiplication. So I can take that common difference, 2, and multiply it by the number of times that it's been added, which here is 5. Which is actually my term number minus 1, because the first number we didn't add anything to. We just started with that. It wasn't until our second number that we had done our common difference. At our third number, we'd done it twice. At our fourth number, we'd done it 3 times, 4 times, and 5 times that we'd added that. So we add that on to where we started originally, and that gives me 11, which is the value of my 6th term here. So my framework, the part that's going to stay the same every time here, is going to be a of n equals the value of our first term, where we start. We're going to add on to that n minus 1, so our term number minus 1, the term before, the number of terms before the one we're looking for, sorry, times our common difference. So if we're looking for the 100th term, we're going to multiply our common difference times 99, 100 minus 1, and then add on where we started. So again, this is our first term. This is our common difference. And this is for our explicit formula. Our explicit formula lets us find the exact value we're looking for with exactly one equation. Whereas the recursive formula, we have 2 rows of formulas where we have to repeatedly add the common difference. So with recursive, we have 2 rows and we repeatedly add that common difference. With explicit, we have exactly one equation that lets us find the exact term we're looking for without having to find everything beforehand. An online auction works as shown on the top of page 277. So here they tell us our term number, or our number of bids, are 1, 2, 3, and 4. And the value of them, or how much was bid, which is our A of n. The first bid was $200, then it was $210, then it was $220, and then it was $230. So here is our sequence. We want to write an explicit formula. So here, A of n, the amount of any term, is going to be the first term plus n minus 1 times our common difference. We're going to take our common difference times itself, times 1 time less than the term number we're looking for. So here we started with 200. To go from 200 to 210, we add 10. Here we add 10. Here we add 10. So our common difference is going to be 10. That goes in here. This is our explicit formula, which is exactly one formula that'll let us find the exact value we're looking for. Here we want to know the 12th bid. So my bid number is 12. We plug that in for n. So the amount of our 12th bid is going to be 200 plus 12 minus 1 times 10. We're going to add that 10 on 11 times to our original number. So we're actually going to add 110, and A of 12 is going to be $310. So our 12th bid would have been $310. Now, a subway pass has a starting value of $100. After one ride, the value of the pass is $98.25. So first term is 100, then $98.25. After 2 rides, its value is $96.50. After 3 rides, its value is $94.75. We want to write an explicit formula to represent the remaining value on the card as an arithmetic sequence. Okay, so we're going to write an explicit formula. Here, the amount of any term is going to be our first term plus n minus 1 times our common difference. Again, that is our framework. That's what we're going to use every time. Here, our first term is 100. And our change every time, we actually go down each time. Each of these numbers is smaller by $1.75. So we drop $1.75 there. So it's a negative. This is our explicit formula. One thing here I want to note, guys, we can also write our multiplication in the front if we wanted. It could be 100 minus 1.75 times n minus 1. So if it's written this way, don't be confused. We can multiply in any order. We can take 2 times 3 to get 6 the same way we can 3 times 2 to get 6. So it doesn't matter which way we multiply. whether it's at the end or at the beginning, as long as we're multiplying it by our n minus 1. That's our explicit formula. We want to know the value of the pass after 15 rides. So here we have to be a little bit careful here. They want after 15 rides. Our first term we didn't ride yet. After our first ride, it told us it was 98.25. After our 2 rides, the value is 96.50. After 3 rides, it's 94.75. So this is actually our first term, our second term, our third term, our fourth term. To get our 15th ride, we actually are going to be on our 16th term. Because again, we had 16 things happen. First we bought the card, then we rode, then we rode, then we rode. So we're looking for N16, our 16th term here. Which, and again, I could have plugged it into this one as well, means we're going to take that $1.75 it costs us per ride 15 times, which is what we want, because we want 15 rides. And this is going to give me 26.25. So the amount of our 16th term, or the value of our 16th term, how much we have left after 15 rides, is going to be 73.75. So just be careful on what you're trying to calculate on the last one. Every one of our terms was a bid. Here, only our last 3 were rides. So we had to adjust that term number just a little bit. Here, we start off with a sequence represented by a recursive formula. And the first term is 19. So what that's telling us is a of 1 equals 19. We want to write the explicit formula. So with an explicit formula, remember, it's exactly one equation to find the exact value we want. So we want the value of any term is going to be our first term plus n minus 1 times our common difference. If we look here, it tells us our first term is 19. And this 12 here, we know in a recursive formula, is what we add every time. That's our common difference. And that's what we multiply by the end here. So that's my explicit formula. Now, feel free to pause here and give this a try if you'd like. We start off with recursive formula. Remember, recursive formula has 2 rows and we have to repeatedly add. We're looking for the explicit formula, which is exactly one equation to give us the exact value we need. A of n equals our first term plus n minus 1 times our common difference. First term here is 21, and our change every time is 2. Again, feel free to pause and give B a try. Recursive formula is a of n equals first term plus n minus 1 times our common difference. Here, first term is 2, and our change every time, that common difference, is what we add every time in a recursive we multiply by in an explicit. And that is our explicit formula. Here we're working backwards. We have an explicit formula, exactly one equation to get the exact value we need. We're looking for the recursive formula. And remember, with the recursive formula, we have 2 rows as part of our equation. We say the amount of our first term equals, and then we put our first term. Here, 32. Then we say the amount of any term is going to be a of n minus 1, the amount of the term before it, plus our common difference. And here my change every time is 22 from that explicit formula. So remember, this is our first term. This is our common difference. This is our first term. This is our common difference. Now feel free to pause here and give this a try. We're starting with an explicit formula, writing a recursive. So recursive, again, we always have to say our first term. We start at 76. Then the value of any term is going to be the amount of the term before it plus our common difference. This is my common difference of 10. So there we go. Same idea here in B. A recursive formula has 2 rows, and we have to repeatedly take our term before it and add on our common difference. First term here is 1. That's where we start. Common difference here is 3. That's what we add every time. And there is our recursive formula. So we can go back and forth between the 2. Quick recap here. Some sequences have function rules that can be used to find any term of the sequence. When the pattern is identified, the sequence can be extended. And that's all for section 4.7.